For today's video, we're going to talk about solving for variables and maintaining equality. So I have a few of these problems already solved. I'm going to kind of walk through what exactly happened and what we did. Starting with the top one, z plus 2.34, 2 and 34 hundredths, is the same as or equal to 6.8 or 6 and 8 tenths. Understanding that I want to maintain equality while still solving for what z would equal, what students have been working on is we called this isolating the variable. I want to get z all by itself. In order to do this, I need to somehow get rid of my plus or positive 2.34. Well, to do that, I use the inverse operation, which the opposite of addition is subtraction. So I'm going to subtract 2.34. But to maintain this equality, we've been working with this strategy that we called a train track, where we're showing if I do something to one side, I have to maintain equality and do that to the other. So I'm going to take 6 and 8 tenths minus my 2 and 34 hundredths. Students are allowed to use a calculator at this point. We're more concerned with the strategies than the computation itself. And what we'd end up getting is z by itself. These cancel out. And when you subtract, you get 4 and 46 hundredths, or 4.46. Over here, this one's a little bit more challenging because what I hope that students can recognize is 2.94 minus q equals 1.3. This equation can be rewritten to 2.94 minus 1.3 equals q just by understanding our fact triangle. And these fact triangles are things that students have been working on since elementary school, where they would understand that 2.94 is on the top, and we can write the different equations off this. We could either 2.94 minus q, 2.94 minus 1.3, and you're going to end up seeing the relationship between all of these. Well, this allows for me to solve easily for q. I would just subtract these, you get 1.64, and now if you wanted to check your work, you'd be able to just put in q, 2.94 minus 1.64, and you're going to end up with 1 and 3 tenths. If students did still try to maintain equality by rewriting this and then subtracting the 2.94 and subtracting the 2.94, again, they're still proving equality, but the issue is you're going to end up with a negative q and it equals a negative number. Well, this is the same thing as long as they understand what they're doing is you'd have to multiply by -1, and this is a little more advanced than what they need to be at because we're not working with negative numbers quite yet. But if they multiply by -1, then they would be getting q equals 1.64. Moving on to when we have fractions, it's the same type of strategy. So over here, y minus 2/3 equals 1/4. We need to somehow isolate y, get y by itself. So we're going to add 2/3. The opposite of minus 2/3 is add 2/3. Over here, you add 2/3. They can use calculators, but they should be able to understand 1/4 plus 2/3. Our least common multiple we're going to get 12. So we find the common denominator of 12. 1/4 is 3/12. 2/3 is 8/12. We add them, and we're going to get 11/12. Now you could plug this back in, and you should be able to prove that 11/12 minus 2/3 gives you 1/4. Over on this side, y plus 1/2, well, the opposite of 1/2, or plus 1/2, would be minus 1/2. We subtract, these cancel out. But to maintain equality, we subtract half over here. 3/4 minus half. Half is the same thing as 2/4. And we end with y equals 1/4. And anytime you solve these equations, you can always prove your answer by just simply putting or plugging this number back in. So the value for y is 1/4. And 1/4 plus 1/2 gives us 3/4. Bada bing, bada boom, you know that your answer is correct, and you've just shown that you have proof. We're going to move into some multiplication and division ones now. These ones have fractions. Now, one of the things that I want the students to understand is 2/3 m equals 6. I could rewrite this. This is really 2/3 times m equals 6. Now, 2/3 times m, I can rewrite this as 2/3 times m over 1 equals 6. which really, a little trick that we can do, not really a trick, but with the math, we can just plug m up on the top. So we're going to have 2m over 3 equals 6. Now, what we could do is we can either solve, understanding that 2/3 times m, I would need to do the reciprocal, which is 3/2, because I would be doing the division. So when I divide by 2/3, we're actually multiplying by reciprocals. And I'm going to prove that over here. So if I rewrite this, and on this side, I multiply by the reciprocal, which is 3/2, I do the same thing over here. And what you'd notice is 3 and 3 cancel, 2 and 2 cancel, and you're left with just n. So proving this, these cancel out. 3 times 2 is 6, 2 times 3 is 6, and 6 is just one whole. What you're left with is m equals, and all you have to do over here is solve. And you should know that 6 over 1 is the same thing as 6. We multiply across. We get 18 over 2. Because we get 18/2, we know that that answer is 9. Otherwise, you could have simplified beforehand. 6 and 2 could both be divided by 2. You get 3, you get 1. 3 times 3 is 9. 1 times 1 is 1. M equals 9. Understanding that this here is just another way to prove that we can just, instead of using division, the opposite of multiply is divide, but we're multiplying by the reciprocal when we're working with fractions. So using that idea over here, 2/5 times k, so we know it's a multiplication problem. Well, to get k by itself, or isolate k, we multiply by the reciprocal of 2/5. The reciprocal of 2/5 is 5/2. Now, 5/2 and 2/5, you'll see they cancel each other out. I'm left with k, but what I do to one side, I have to do to the other. And this is where we're going to have to start showing some work. 1/3 times 5/2, and we're going to multiply across, and we get 5/6. Now, I can always prove my answer. So if I have a calculator here, I should just be able to type in 2/5. Knowing that k is 5/6, I can type in times another fraction, 5/6, and we equal 1/3. So hopefully students with calculators are able to start seeing how I can plug my answers back in, check my work. We're really starting to move towards more of that algebraic reasoning. Over here we have p divided by 4 equals 12. Well, the opposite, I could rewrite this as p over 4 equals 12, and the opposite of either 1/4 is to multiply by 4 over 1, or the opposite of divide by 4 is just multiply by 4. So what I do to one side, if I'm going to set this up, multiply one side by 4, multiply the other side by 4. These isolate, and I get p, or those cancel, and I isolate p to be p equals 48. 12 times 4 is 48. Plug it back in, make sure it makes sense. Is 48 divided by 4? Oh, you get 12. Here, 36 divided by something equals 9. Now, the majority of students understand that they can just get an answer using this. 36 divided by 4 is 9. But I want them to be able to show either an understanding of their fact triangles. Here's 36, here's v, here's 9. They can rewrite this problem as 36 divided by 9 equals v, and they would end up with v equals 4. Otherwise, they would have to multiply across by v. Now, if you multiply v here, rewrite the problem, 36v divided by v equals 9. You multiply by v, you multiply by v. These cancel. You're left with 36 equals 9v. And now we prove that we can divide by 9. Divide by 9. You cancel these out. You are left with v. 36 divided by 9 is 4. So regardless, what you do to one side, you just have to maintain or have to do to the other. The last type of problems are the same, just now we're going to get into fractions and decimals. So c divided by 4.2 is equal to 20. What you're going to have to understand is I'm using the inverse. What's the opposite of divide by 4.2? To maintain equality, I would have to multiply by 4.2. What I do to one side, I do to the other. I'm left with c, these cancel. And what I have is 20 times 4.2. And kids can use calculators. And you get 84. So c is 84. 84 divided by 4.2. If you wanted to type this into your calculator just to prove it, 84 divided by 4.2 equals 20. We're proving our answers. Next, n plus 4/10 or 0.4 equals 4/5. Well, fractions and decimals, I need to be able to convert back and forth. So if I want to turn this into a fraction or this into a decimal, it doesn't matter either way. This here is 2/5. This here would be 8/10. Now, simply subtracting 4/10 is the same thing as 2/5. So I would subtract, because opposite of add is subtract. So I would subtract 2/5 over here. And what I'm left with is n equals 2/5. So proving equality. What I do to one side, I have to maintain or do to the other. I could have also turned this and said 4/5 is equal to 8/10. 8/10 minus 4/10 is 4/10. And the decimal for 2/5 is 0.4, 4/10. Here's where it gets a little bit more confusing. We have 8 equals 2 3/4 y. Well, to understand this, we have to figure out what fraction this actually is. Right now, this is just a mixed number. So if I was going to turn this into a fraction, we talked about a half clock, so we're going to multiply and add. We take our denominator, 4 times 2 gives me 8, so 2 is 8/4, plus 3 more fourths gives me 11/4. So I have 11/4 y equals 8. Well, to do this, I need to say 11/4 times y. I could do divide by 11/4, divide by 11/4, but when we're actually doing division of fractions, we're multiplying by reciprocals. So I can take here, and I'm multiplying by the reciprocal of 11/4, which is 4/11. And I'll prove it over here. 11/4 times 4/11 equals 44/44, which is equal to 1. These cancel out. So we just get one whole. What we're left with then is y. Now, what I did to this side, to maintain equality, I have to do to this side. So I get 4/11. 8 times 4/11. Well, if I rewrite this, it's really 8/1 times 4/11, and we would get 32/11 is equal to y. And we can definitely leave it like that because 11 is prime. We know we can't simplify it at all. Otherwise, you could just rewrite this as a mixed number. It's totally up to you. I'm just going to leave it there. Here, 5.5g or 5.5g equals 16.5. What I do to one side, I'd have to do to the other. How do I get g by itself? I need to isolate it. So opposite of multiply, divide. And you'll notice I use the fraction bar, which also means division. These cancel out now. I'm left with g. Well, if I divide this side by 5.5, I divide this side by 5.5. And now 16.5 divided by 5.5. Just use your calculator. 16.5 divided by 5.5. And we get 3. So g equals 3. Now if I wanted to prove this, I simply just type in my calculator 5 and 5/10 times 3, you get 16.5. So right now, back and forth, you should be able to prove your answers, but really it's all about maintaining that equality. And I know some teachers are going to require you to show the train tracks the whole way through. As long as you're showing me how you're maintaining equality, that's fine. And calculators are definitely allowed, but please make sure you're showing what you're doing with that calculator. Thanks for watching. Hopefully this helps. Please let me know if you have any other questions.